Have you ever thought about this question? When you make a wish in the glow of birthday candles and cut into that soft, sweet slice of cream cake, where does it actually come from? Is it handcrafted by a pastry chef in a small workshop, or does it come out of a giant industrial machine? The answer might surprise you. Around the world, more than 1 million cakes of all kinds are produced every single day. They come from food factories in Italy, central kitchens in France, and frozen production facilities in Japan. From there, they flow continuously to cafes, bakeries, supermarkets, convenience stores, and hotels all over the world. Behind all of this is a system often described as a cake printing machine, powered by 100-meter-long industrial baking tunnels, high-pressure steam injection systems, and millisecond-level precision algorithms working in sync. There are almost no people visible on the production floor, yet every second, a freshly baked cake comes out and is shipped to destinations around the globe. Today, Food Truth will take you deep into this mysterious modern cake factory to see how humanity uses industrial-scale power to transform desserts once defined by craftsmanship into a food industry miracle of mass production, driven by cold machinery, yet capable of producing at astonishing scale. Before we explore the factory, let's talk about something first: the industrialization journey of cakes. More than 100 years ago, cake was an extremely luxurious food. It required fresh eggs and expensive butter, scarce refined white sugar, and several hours of manual work by a pastry chef. In European aristocratic households, enjoying a carefully prepared cake during afternoon tea was almost a symbol of social status, but the Industrial Revolution changed all of that. Fast forward to the late 19th century, refined flour began to be mass-produced on an industrial scale. Sugar, boosted by global trade, became a widely available and inexpensive ingredient, and the invention of the electric oven completed the final piece of the technological puzzle. Cake, once a luxury item, started to become accessible to the general public. By the 1950s, the United States introduced a groundbreaking innovation: cake mix. All you had to do was open the package, add water and eggs, mix it, pour it into a baking pan, and you could make a decent cake at home. That marked the first step in the democratization of cake. But what truly turned cake into a mass-produced assembly line product was the rise of the central factory model. Entering the 21st century, demand for cakes exploded. Any small bakery would quickly become overwhelmed with daily orders. As a result, a new business model emerged: industrial frozen cakes. Take Japan, for example. A leading company specializing in frozen cakes can produce 150,000 frozen cakes per day. After being fully assembled in the factory, these cakes are rapidly frozen to temperatures below -35 degrees Celsius and then shipped worldwide through cold chain logistics. All it takes is a few hours of thawing at room temperature for them to regain a texture almost identical to freshly made cake. In China, large-scale central baking factories operate at a similar level of efficiency. Some can produce up to 500,000 mooncakes per day during peak seasons. This is the astonishing power of modern food industry manufacturing. So the question is, how exactly are frozen cakes made? Now follow me into this magical cake production line. The starting point of the entire process is an area workers call the sanctuary of ingredients. Here you can see not only a wide variety of raw materials, but also production machines made entirely of stainless steel. The first ingredient to appear is flour. Every single gram is precisely controlled by a computer system, with an error margin of no more than 1/1000th. Why such extreme precision? Because cake, although it looks simple, is actually the result of an extremely delicate chemical reaction. If you add 5 grams too much flour, the cake becomes dense and hard. If you reduce sugar by just 2 grams, the color won't reach that perfect golden tone. If you add 10 grams too much egg mixture, the texture becomes overly rich and greasy. From a company's perspective, ingredients are never adjusted by feel. Instead, everything is determined through scientific precision, ensuring that every single cake tastes exactly the same. Next comes the egg mixing process. This is arguably one of the most spectacular scenes in the entire factory. At home, you might crack just 2 eggs to make a cake, But in an industrial production line, eggs are handled in quantities of tens of thousands at a time. Robotic arms reach into trays of eggs and, like octopus tentacles, simultaneously grab dozens of them, feeding them into a precision device known as an egg separator. This machine can process 2,000 eggs per minute. Its mechanism is not overly complex. A high-speed rotating disc, fitted with hundreds of cup-shaped holders, each one designed to catch a single egg with precision. Then, an ultra-thin metal blade instantly cracks the shell open, guiding the yolk into a designated channel. Meanwhile, the egg white flows through tiny openings into a collection tank below. The entire process takes less than 0.5 seconds, with a separation purity of over 99.5% for yolks and whites. This level of precision is something no manual process could ever achieve, and the egg yolks and egg whites that are separated are then sent to different production lines. Egg yolks are typically used for sponge cakes, chiffon cakes, and custard. Egg whites, on the other hand, are used for angel food cakes and macarons. Next, all ingredients are transported, according to the recipe, into a massive mixing tank. These industrial mixers often have capacities of 500 to even 1,000 liters. The mixing blades are powered by motors equivalent to about 1/3 of a family car engine. They rotate at carefully controlled speeds and directions, blending flour, sugar, egg mixture, vegetable oil, baking powder, and water into a perfectly smooth and uniform cake batter. This step may look simple, but it is actually the key to the cake's texture. If overmixed, the gluten in the flour becomes overly developed, and the cake turns rubbery and tough. If undermixed, air bubbles are unevenly distributed, and the cake may collapse during baking. In factories, mixing time is controlled down to the second, and every batch is identical, with zero deviation. The prepared batter is then pumped through a transparent pipeline to the next station, the depositing machine. Beneath the depositor is a conveyor belt that never stops moving, with thousands of metal baking trays neatly lined up on it. Each tray has already been fitted with cake molds. The nozzles of the depositing machine release batter in an extremely precise rhythm and measured amount. No more, no less. Exactly 60% of the mold height is filled. But why 60%? Because during baking, the cake expands to more than 1.5 times its original volume. If the batter is filled too full, it will overflow the mold during baking, causing significant waste. If it is filled too little, the cake won't rise high enough, which affects its appearance, and commercial appeal. This 60% golden ratio is the result of countless experiments and accumulated industrial experience. After the depositing process is completed, the baking trays are carried by conveyor belts into the largest piece of equipment in the entire factory, the tunnel oven. This type of oven can be 200 to 260 feet long. It lies across the workshop like a glowing metal dragon, constantly releasing waves of heat mixed with the aroma of baked flour. Inside, the oven is divided into multiple temperature zones. The peak temperature can reach up to 1,000 degrees Fahrenheit. The trays slowly move through this fiery tunnel at a speed of just a few meters per minute. The entire baking process is precisely controlled within 23 to 25 minutes. The secret of the tunnel oven lies in its zoned temperature control. At the entrance, the temperature is lower, allowing the batter to warm gradually and expand evenly. In the middle section, it enters a high-temperature zone, where the cake surface quickly forms a golden caramelized crust. At the exit section, the temperature drops again, stabilizing the moisture inside the cake. If the entire oven were kept at a single temperature, the outer layer would burn black, while the inside would remain underbaked and unrisen. This is the key difference between a home oven and an industrial-grade baking system. A single tunnel oven can achieve an energy efficiency of 60% to 70%. In other words, nearly 70% of the electricity consumed is effectively converted into usable baking energy for proper cakes. The remaining energy is lost to the surrounding air. This number may not sound extraordinary at first, but compared to the roughly 30% efficiency of a household oven, it is already an industrial miracle. When the cakes come out of the oven, they have already transformed from a liquid batter into golden, fluffy, aromatic finished cake bases. Each piece is nearly identical in size, color, and height. This is the terrifying power of industrial standardization. But the baked cakes still have to go through one crucial step: demolding. Factories use a vacuum suction demolding machine. Its principle is similar to an octopus's suction cups. A robotic arm slowly descends, aligning itself precisely with each cake in the tray. Air is pumped out to create a vacuum pressure, gently lifting the cakes out intact. They are then carefully placed onto the next conveyor belt. Throughout the entire process, the cake surface is never compressed, and the edges remain perfectly intact, preserving the airy structure formed in the oven. After demolding, the cake bases are sent to the slicing station. This step requires an almost extreme level of precision, because most layered cream cakes and sandwich cakes are made by stacking 3 to 4 thin layers of sponge cake, and each layer must be strictly controlled to about 2/3 of an inch in thickness, with a tolerance of no more than that fraction of an inch. The machine used here is called a horizontal slicer. Its working principle relies on several ultra-thin steel wire blades that vibrate at extremely high speeds, over 3,000 oscillations per minute. As the cake moves through the wires, they pass through it almost effortlessly, instantly slicing a whole cake into 3 to 4 perfectly even layers. The brilliance of this technique lies in vibration rather than force. If you use a normal knife to cut a soft sponge cake, the pressure of the blade will compress it, resulting in a rough, uneven surface. But a high-frequency vibrating wire can cut through without applying downward pressure, preserving the cake's delicate structure and appearance. This technology is actually borrowed from the medical device industry. The soul of a cake is always its filling and outer cream layer. In factories, cream production is also a kind of chemical symphony. Inside giant industrial mixers, ingredients like cream, powdered sugar, vanilla extract, and stabilizers are combined and whipped at carefully controlled speeds until they form a light, fluffy, and stable mousse-like structure. Industrial cream like this is far more stable than hand-whipped cream made at home. It can hold its shape for 4 to 6 hours at room temperature and remain stable for more than 7 days under refrigeration. Next comes the filling stage. The cake layers are transported by conveyor belt to a station known as the spreading machine. At the heart of this machine is a rotating nozzle system that applies cream, jam, or chocolate sauce evenly across each cake layer. The thickness of the coating can be controlled down to 0.0118 inches. To put that into perspective, that's roughly 3 times the thickness of a sheet of A4 paper. After the filling is applied, the machine initiates the stacking process. A new layer of cake is placed perfectly on top of the previous one, aligned with near-perfect precision. The entire process takes less than 3 seconds. Next comes one of the most visually striking steps, the glazing stage. The entire cake base is moved into an open spray tunnel. Dozens of high-pressure nozzles are installed overhead. The machine simultaneously sprays a precisely measured amount of cake glaze, while the cake tray slowly rotates underneath. The surface becomes evenly coated as the glaze flows downward, and any excess is collected in a recovery channel below. After being heated and filtered, the excess glaze is recycled back into the spray system. This zero-waste design allows factories to achieve over 98% raw material utilization. If the earlier steps represent the power of industry, then the decoration stage represents the romance of industry. Here you will see the most sophisticated equipment in the factory: 6-axis decorating robotic arms. These robotic arms are originally derived from automotive manufacturing technology, but in cake factories, they have been transformed into pastry artists. At the end of each robotic arm is a replaceable piping nozzle. Through pre-programmed algorithms, a single arm can draw 12 perfect buttercream roses on a cake in just 3 seconds, or even write out "Happy Birthday" with flawless precision. Even more impressively, multiple robotic arms can work together. One is responsible for sprinkling sugar pearls, another pipes the cream, and another places fruit on top. Their coordination is so seamless, it resembles a silent industrial ballet. Even more astonishingly, many high-end cake factories now use AI vision systems. Each cake that is about to be decorated is first scanned by a camera. The system analyzes its height, width, and surface smoothness, then adjusts the robotic arm's trajectory in real time. This ensures that even cakes with slight size variations can still be decorated with perfect consistency. A level of intelligence like this would have been unimaginable in cake factories just a decade ago. Once decoration is complete, the cake moves to its final stage, freezing and packaging. Right after decoration, the cream inside the cake is still very soft. If it were packaged immediately, it would be a disaster. So the factory first sends the cakes into a rapid freezing tunnel. The temperature of this tunnel is maintained at below -35 degrees Celsius. Cold air circulates at a speed of 5 meters per second, and the cakes remain inside for about 30 minutes until the core temperature drops below -18 degrees Celsius. The advantage of flash freezing is that it locks moisture in place before ice crystals have time to grow. As a result, when the cake is thawed later, its texture is barely affected. In contrast, slow freezing allows large ice crystals to form, which can rupture the cake's cellular structure. After thawing, the texture becomes rough and watery. Once frozen, the cakes are moved to the packaging area. Automatic packaging machines wrap each cake in plastic film, then use nitrogen replacement technology to remove air from the packaging. Pure nitrogen gas is injected into the package. Nitrogen is an inert gas that does not react with food through oxidation, significantly extending shelf life by more than 3 times. Finally, labeling machines automatically print production dates, expiration dates, and ingredient lists. Each cake effectively receives its own identification card. The boxes are then loaded onto refrigerated trucks and shipped to supermarkets, cafes, and convenience stores across the country. This is the complete industrial cake production line. But in reality, cake factories are far more complex and far harsher than most people imagine. The first invisible battlefield is hygiene. Cakes, rich in sugar, protein, and moisture, are an ideal breeding ground for bacteria. Factories must therefore enforce extremely strict hygiene standards. Before entering the production area, workers must pass through an air shower room. Powerful jets of high-pressure air blow away dust, hair, and skin particles. Workers must wear specialized cleanroom suits. Hair must be fully covered with triple-layer hairnets. Masks, gloves, and protective shoe covers are all mandatory. The air inside the workshop is filtered through HEPA systems. The number of airborne particles per cubic meter must not exceed 3,500. This standard is even stricter than that of hospital operating rooms. Every production line must be shut down every 4 hours for a full cleaning and disinfection cycle. Every day after production ends, the entire line is washed down with water above 85 degrees Celsius. It is then sprayed with food-grade disinfectants. These procedures are usually carried out in the middle of the night. The second challenge is a cost war. You might think factory-made cakes are highly profitable, but that would be a serious misunderstanding. Industrial cakes have very low unit prices, and profit margins often range only between 5% and 15%. This means factories must rely on scale to make money, and behind that scale lies extreme optimization of every gram of ingredient, every kilowatt of electricity, and every second of time. Energy managers continuously monitor the power consumption curves of each oven. If the energy usage of a production line suddenly rises, the cause must be investigated immediately. Even a 1% waste when scaled to 100 million cakes a year can translate into losses of over $1 million. The third challenge is an innovation war. Driven by economic and cultural shifts, food trends change constantly. Consumer preferences evolve just as quickly. One month it might be molten cheesecakes, the next month fresh fruit cakes, and the month after that, salted egg yolk savory cakes. Every new flavor trend forces factories to adjust formulas, equipment, and processes. R&D departments in factories may employ dozens of food scientists. Their job is to constantly experiment, taste, and document results, trying to replicate the handmade feel of small bakeries while maintaining large-scale industrial production. It is a never-ending technological marathon, and although modern cake factories are highly automated, you might think there is no human involvement at all, but that is not necessarily true. Along each production line, there are still several workers standing by. Their tasks may look minor, but they are absolutely essential. Some are responsible for inspecting every cake on the baking trays, removing any defective products. Some refill cream for the decorating robotic arms, ensuring the machines never stop due to a shortage of ingredients. Some monitor screens 24/7, watching real-time equipment data to ensure everything runs normally. The moment anything goes wrong, they must respond within 30 seconds. And the hardest job belongs to the workers who, between 2 a.m. and 6 a.m., wear heavy insulated clothing and move cakes inside minus 20 degrees Celsius freezing rooms. Their shifts are often completely reversed from normal day-night cycles, and their pay is not particularly high. Yet it is precisely their persistence that allows us, on a sunny afternoon, to walk into any cafe and enjoy a soft, sweet slice of cake and experience a brief moment of comfort and joy. This is one of the least visible sides of modern food industry. Next time you taste a delicious cake on a special day, remember that somewhere out of sight, there is a massive factory working continuously, thousands of machines running, hundreds of workers busy at their posts, and countless scientists developing new formulas, all just to bring that small piece of cake to your table. It is not born from the hands of a single pastry chef. Instead, it emerges from a system woven together by human intelligence, industrial power, and precise algorithms. This is the most poetic side of modern food manufacturing, using the cold precision of machines to preserve humanity's softest taste memories. After watching this video, do you prefer handmade, one-of-a-kind cakes, or highly standardized industrial cakes? And can you actually tell the difference between the two? Let me know your thoughts in the comments. This is Food Truth. If you enjoyed this video, don't forget to like and subscribe. Join us as we continue exploring what happens behind food factories and uncover the industrial wonders hidden inside every bite.